Mhm. 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 How is everybody? All righty. So go ahead and get out your packet that I emailed you. Let me get my screen where I can see everybody. See if we're missing anybody. Okay, so let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Just missing one. We got, is it Evelyn? Yep, missing Evelyn. Oh, very good. Evelyn is with Kinsley. Awesome. All righty, so we've got everything, everybody. Yay. All righty, so let's go ahead and take a look at the packet that that I emailed to you guys, and we'll take a look over it and kind of see the things that we've already learned how to do, talk about each part of it, make sure everybody's got it. Okay, so I did go in and tried to label it and give y'all some information, put the lesson that it correlated with. So the first one is worksheet 15, and you can see at the top, I put in page 1. I numbered it page 1. It goes along with lesson 30, and it says complete the chart to find y using the given values for x and then graph. Okay, so in lesson 30, we learned about setting up our tables, that we use 0, 1, 2, -1 and -2 as our 5 values for x. And then we just plug those numbers in to be able to solve for y. Then we have our x value and our y value. So that gives us points to graph. Okay, so let's go ahead and look at that first one. I want you to be super, super careful. Remember, we talked about how when I am plugging in, that I always want to go ahead and make sure to put parentheses around the x, okay? So in this situation, I've got a negative there in my original equation. So when I plug in my value, I've got to pay close attention to that negative. So in the first one, I would have y equals -0 plus 1. Well, obviously -0 doesn't matter, and 0 plus 1 is just going to be 0. So if x is 0, I said 0, good grief, it's not 0, it's 0 plus 1. So then y is 1. Okay, and the next one, x is 1. So y equals, I already have a negative, I put 1 in parentheses plus 1. Well, -1 plus 1 is 0. So if x is 1, y is 0. The next one, y equals, I've got a negative in my equation. I put my 2 in parentheses, add 1. -2 plus 1 is -1. So if x is 2, y is -1. This next one, y equals negative. In parentheses, I'm putting a -1. So a -1 is the same as a +1. Now, one of the things I'll tell you that I saw something, and this may be helpful to you guys, it may not, it's totally up to you. But I was working with a student yesterday that what she did is if she sees a negative and a negative together, she goes ahead and combines them to make a big positive. And I thought that might be helpful for you. If you have two negatives together, then you can connect those two negatives and make sure you turn it into a positive. May work for you, may not, whatever you want to do. So now I have 1 plus 1 is 2. So I found that if x was -1, y was +2. Again, y equals, my negative is my equation. I'm plugging in a -2. If you want to use that same format, you can combine the two negatives to make a positive. So now I have +2 plus 1, so that's a +3. So if x is -2, y is 3. And then you would use your graph. That's a bad one. All right, I can use my graph. Remember, this is x, this is y. 0, 1 means I stay at my origin and I go up 1. 1, 0 means I go right 1, stay at 0. 2, -1, I'm going to go right 2, down 1. -1, +2 means I go left 1, up 2. And then -2, +3, left 2, up 3. I can see my line and I can graph it. Okay, so plug in your values. When you're plugging in x, make sure that you put it in parentheses to help you pay attention if there's a negative already there in the equation, because that's especially going to come into play when you're plugging in a negative value for the value of x. Okay, so you're completing your chart and graphing. All right, so that's what you're doing here. Now notice, pay close attention when you got your parentheses, when you've got to distribute, okay? Or you just do your functions, or you do your order of operations, and when you plug in x, do what's in parentheses, multiply, and then go from there. Any questions on worksheet 15? Okay, plug in your values for x, solve for y, plot your points, graph your line. Let's look at page 2, lesson 31. It says to find the slope of the line by counting the rise over the run from point to point. So I'm going to highlight that right there. All right. So remember, when I'm counting, I'm starting at one point and going to the other. Okay. So if I'm going from my point at my origin, and remember, slope equals rise over run. So that means I'm either going up or down, and then I'm going left or right. Okay, so if I'm starting at this point here, I'm going up 1. So that's a positive number, and to the right 2. So that's a positive number. So if I went up 1, that's my numerator, and right 2, that's my denominator. So my slope is 1/2. Now, let's say I had decided that I was going to start with the other point, and I went from here first, and I went down 1, that would be -1, and left 2 would be -2. So then I have -1 over -2, which is the same as 1 over 2. So it does not matter which point you start with, you're going to get the same slope. Okay, so you could start, it does not matter which one you start with and go to the next. you're going to get the same slope. So that's all you're doing on this page is you're just counting them. Are you going up and right, down and left? What direction are you going to determine your slope? Okay, no calculations, just drawing. Okay. But pay close attention to number 5 and number 8. Think about what is the slope of a horizontal line? What is the slope of a vertical line? Uh-oh, and I didn't move my, sorry about that. When I made this one, I did not move. I just put that m equals right smack in the middle of that graph. Sorry about that. Okay. Page 3 says, now we're going to use the slope formula to determine the equation. Plug in the x and y values and solve for m. Show all work. Okay, so I want to see your work on here. Slope formula. M is equal to y2 minus y1 over x2 minus x1. Okay, remember what my equation is? If I'm using these and I said this was x1, y1, x2, y2. I'm going to have my formula. M is equal to y2 minus y1 over x2 minus x1. So I look and I say, okay, y2 is negative 15 minus y1 is negative 16. Again, pay attention with your signs. x2 is negative 7 minus x1 is 19. So, like I said, if you want to look at this and say, hey, I've got two negatives together, that becomes a positive. So now I have got negative 15 plus 16. Negative 15 plus 16 would be a positive 1 over negative 7 minus 19. I owe mom $7. I just borrowed 19 more. I owe her $26. Now, I hope you never have to graph a graph that has a slope of 1 over negative 26, which is the same as negative 1 over 26, because that means you would either go up 1 and to the left 26 places, that's going to be a big old graph, or you're going down 1 and right 26 places. But either way, my slope of this one is negative 1 over 26. Remember, your negative can be out front, it can be in your numerator, it can be in your denominator. Totally up to you. Okay? Use your slope formula and show your work. This is what I mean by showing your work. Okay, I want to see where you plugged in your values and solved. Now, the main thing to remember about slope, though, is my slope is expressed as a fraction, and I always want to make sure it's in simplest form. So if you can reduce your numerator and denominator, make sure you do that. Okay? Any questions about page 3? All right. Moving on to page 4. Page 4 goes with lesson 32. And it says, make sure the equation is in slope-intercept form. So that's step 1. Step 2, identify the slope and the y-intercept. So you need to write your equation in slope-intercept form. I need to see that. And then I put a place for you to put the slope and the y-intercept. Okay. So let's look at number 1 as the example. Now, it is already in slope-intercept form, y equals mx plus b. So if you want to, y equals mx plus b. That's slope-intercept form. That's what you've got to make sure you do. So if I have y equals mx plus b, I can see that m is negative 5 over 2. Remember, my value for m is only a number. It does not include x. My slope does not include the variable x. It is just the number that comes before x, okay? My y-intercept, remember my value of x is always 0. My value of y will be this number right here. Remember, my original equation is plus b. So if you see a negative, you know my number for my value of y is negative. Okay? So that's what you would do for the first one. All you do is put in -5/2 for your slope and 0, -5 for your y-intercept. Let's go down, though, to number 5. Number 5, I've put a place for you to put it in slope-intercept form. Remember, that's y equals mx plus b. So the first thing I've got to do, I'm trying to solve for y. So subtract 2x, subtract 2x. Negative y is equal to -2x plus 1. Now remember, I cannot solve for negative y. I need positive y. So if I need to change my negative y to a positive, I need to multiply everything by -1. -1 times negative y is a positive y. -1 times -2x will be positive 2x. -1 times a positive 1 is a -1. So now I have y equals 2x minus 1. I can look at this. My slope is going to be 2, or you could write it as 2/1. It's up to you. If you want to write it as a whole number or a fraction, doesn't matter. My y-intercept, x is always 0. My value of b is -1. Okay? So on this page, if it's already solved for y, you only have to give the slope and the y-intercept. If it is not solved for y, you have to solve for that first, then give the slope and the y-intercept. Chad?
Why is the 2 positive instead of negative?
Okay, so right here, remember, if I am changing negative y to a positive y, I'm multiplying by -1. But because I have an equation, whatever I do to one side, I have to do to the other. So if I multiply my left side by -1, I have to multiply the right side by -1. And that means I have to multiply every single term. So -1 times -2x becomes positive 2x. -1 times a positive 1 is a -1. You good with that?
Yes.
Okay, because I'm multiplying everything by a negative, I have to multiply each term. Okay. All righty. I know some people are having some Wi-Fi problems, so I'm going to try to pay close attention to who's trying to get back in. I've got my participant list set up, so we'll watch and see if anybody pops up. Okay. So on page 4, first make sure you have it in slope-intercept form, then identify your slope and your y-intercept. Everybody good with that? Questions? All righty, page 5. Now we're taking it a step further. We have slope-intercept form, we have our slope, we have our y-intercept. Now we're going to do the same thing, but we are going to graph it. Okay? So let's take a look at the first one. 7x plus y equals 5. Step 1, rewrite the equation in slope-intercept form. Step 2, identify slope and y-intercept, then graph. So the first thing I need to do is slope-intercept form. So I'm solving for y, so I need to subtract 7x, subtract 7x. So y equals -7x plus 5. When I'm looking at this, so I have y equals -7x plus 5. We'll go in the first blank because that was step 1. It said to write it in slope-intercept form. Now my slope is going to be -7, which is the same as -7/1, which is the same as 7/-1. That helps me when I'm graphing and using my slope. Okay. And then my y-intercept is going to be 0, 5. Now, with my slope being so big, let's look at where I'm going to graph 0, 5. So remember the first step to graphing, okay? If you need the reminder for graphing, step 1 is to graph your y-intercept. Okay, so I'm going to graph 0, 5. 0, 5 means I stay at my origin and move to the right 5 places. So there is, no, good grief, I stay at my 0 and go up 5. There's my y-intercept. Okay, now I'm using, my second step is to use my slope, use slope to identify additional points. Okay, so when I graph, the first thing I do is I graph my y-intercept. So that's what we did here, 0, 5. Then I'm going to use my slope to determine additional points. My slope is -7, so that means I'm either going to go down 7 and right 1, or up 7 and left 1. Well, from my point, I don't have room to go up 7. So what I'm going to do is I'm going to go down 7 and right 1. So I go down 1, 2, 3, 4, 5, 6, 7, and right 1. Now on this one, I don't have room to go anymore. I can't go down 7 or I'm going to be below my graph. So remember, I told you, as long as you have 2 points, you can graph a line. It's better to have 4, to have more, but as long as you have 2, you can graph your line. So now I can go ahead and connect those dots and draw my line. Now, what do you notice about that line? It's a pretty steep line, isn't it? So notice if my slope was -7, that gives me a really steep line. So the larger my slope, the steeper the line, okay? The closer to 0, the closer it's going to be to horizontal, but the larger my number, the steeper the line, okay? So that's what you're doing on this page. Step 1, you are going to do y equals mx plus b, slope-intercept form. Step 2, identify your slope and y-intercept, and then you're going to need to graph, okay? Remember, for graphing, your first step is to graph your y-intercept, then use your slope to find additional points, and then the third part of that is to connect your points. Connect points with straight line with arrows. Okay? Any questions about that? All righty. Page 6 goes along with lesson 33, and this is where we're going to be going back to today. We started talking about, on Monday, we talked about point slope form. So first thing I want you to do is under point slope form, let's go ahead and write that, okay? So point slope form, remember that is going to be y minus y1 equals m times x minus x1. And then slope intercept, y equals mx plus b. Okay, this corresponds with lesson 33. All right, so what we talked about the other day is first you're going to write the point slope form and then convert it to slope intercept. So if I'm looking at point slope form and I'm using y minus y1 equals m times x minus x1, then what I'm doing is, obviously I know m is 4, x1, y1 is my pair, my ordered pair. Okay, so now I just plug it in. I just use my values. So y stays the same, y minus y1 is 3 equals m is 4 times x minus x1 is 2. That's your point slope form. You can leave it just like that for point slope. All you do is plug in the values. Now we have to go from point slope to slope intercept. So I'm going to come over here and I've got y minus 3 equals 4 times x minus 2. Now I've got to solve for y. So the first thing I'm going to do is I'm going to distribute the 4. So I have y minus 3 equals 4x minus 8. Okay, I distributed that 4 because it is outside parentheses. That means I have to multiply it by each term inside parentheses. Now remember, I'm trying to solve for y. The only thing that is with y on the left-hand side now is -3, so I'm going to add it. I'm going to go ahead and put plus 3 under the minus 8 because that's going to be the term I combine it with. So y equals 4x minus 5. So I have gone from point slope to slope intercept. So y equals 4x minus 5. So that's all you're doing here. You're plugging in the values that you have for m, x1, x2. Then you're going to distribute and then solve for y. So after you've distributed, all we had to do here was move that 3. It was negative on the left-hand side, so to move it, I had to add it. That meant I had to add it to the right-hand side too. So that's what you're going to be doing for this beginning part of page 6. Now, the second part of it just says you're going to graph each equation from activity 1. So now you have a point, you have a slope, and you have a y-intercept to be able to graph these. Okay, so you're going to graph. And that is all for the packet. It's everything that we've already covered so far. Like I said, this is due next Thursday. So you've got a week. If you already started it, fantastic. If you haven't, you've got a week to work on this. Okay? Any questions about these? All right. So my recommendation, as you know, is to never wait till the last minute. Do not wait till next Wednesday to do this. Okay, so basically we've got 6 pages. So if you wanted to break it up and you said, hey, tonight I'm going to do at least 2 pages. And then next week I will do 2 pages Monday night and 2 pages Tuesday or Wednesday night, then you've gotten your 6 pages done. But just be sure to break it up between now and next week. You've got 6 pages to do. You know, the first one, there's only 4 problems, 8 problems. What is that? 8, 10. So what I would say is do at least 2 pages a night. Really, I guess if you did 1 page tonight, 2 pages Monday, 1 page, well, 2 pages tonight, 2 pages Monday, then 1 Tuesday, 1 on Wednesday, it's up to you. Just don't wait to do it all last minute because I don't want you to rush and make mistakes, okay? I want you to take your time. Look back at the lesson associated with it, okay? Look back at the lesson if you get confused. Hopefully you wrote down all the things that I just wrote down because I kind of gave you a step ahead with getting some of it done. Make sure you've got your equations identified to help you if you need that, okay? And as always, if you get stuck, let me know. I'll help you, okay? All righty. So we didn't have any textbook homework, if I recall correctly. We had gone through this section. We didn't have any textbook homework. Let's go ahead and take a look back at actually, since we just went through that, let's go ahead and open your book to page 75. Textbook, page 75. This is lesson 34. So lesson 34, we talked about horizontal and vertical lines. Okay. We talked about what is the slope of a horizontal line. Horizontal lines, lines that go like this, have a slope of 0. And the slope of a vertical line is going to be undefined. Okay. So we learned that when I'm looking at the slopes of lines, if they're parallel, they're going to be the same. And then what did we learn about perpendicular slopes? Slide on through. Lesson 36 was perpendicular lines. What did we learn about perpendicular slopes? They are negative reciprocals. Remember, negative reciprocals. That means that one will be positive, one will be negative, and the fraction form of one will be the flipped of the other. Okay, so reciprocal means it's flipped. I've had students that sometimes they call it a refliprical because it helps them to remember that a reciprocal flips. Okay, so negative reciprocals are perpendicular lines. And now we are going to start with lesson 37 on page 81. Okay, so go ahead and turn to page 81, lesson 37. So it says, consider the graph of the line y equals 2x below. Remember we talked about if I'm looking at y equals mx plus b, and this is missing, that just means it would be y equals mx plus 0. Okay, so in this situation, y equals 2x plus 0. That tells me that my y-intercept is at 0, 0, which is right there at the origin. Okay, so just remember, if you see something like this, if it makes you feel more comfortable to go ahead and put a plus 0 so you can have it in y equals mx plus b form, that is just fine. And so that means that my y-intercept is going to be 0, 0. And my slope is 2. So that means I go up 2, right 1, or I can go down 2, left 1. Okay, so using my slope, I can find that. So it says the slope of the line is 2. Now consider the graph of the line y equals 2x minus 2. So remember, if m equals 2 in this situation, and my y-intercept is going to be 0, negative 2. Up here, my slope was 2. My y-intercept was 0, 0. Now, when I look at this and I have my y-intercept is 0, 2, I'm sorry, 0, negative 2, they graphed that and then used the slope of 2. That meant I can go up 2, right 1, up 2, right 1, or I could go down 2, left 1. So I can see where I've got points along that line. Because the slope of both lines are 2, if I put them on the same graph, if I combine them on the same graph, you can see that they would make parallel lines. Okay, let's see if we can get Sadie back in here. So let's look at those together. The first one I had y equals 2x. My second one is y equals 2x minus 2. They both have different y-intercepts, so that means they cross the y-axis at different places, but their slopes are the same. Therefore, you can see that they are perpendicular lines. That means the distance from one line to the other is consistent the entire way, so they will never intersect. Okay? They are the same either way, so they will never intersect. So perpendicular lines have the same, parallel lines have the same slope. So it says lines with the same slope are always parallel. So parallel lines, same slope. Perpendicular lines have negative reciprocals. So let's go ahead and take a look at the activities on classwork 1. So on the first one, my slope is 4. On my second one, my slope is negative 4. And so remember, parallel equals same slope. 4 and negative 4 are not the same. Therefore, they are not parallel because one is, we'll just put one is negative and one is positive. Okay? They are not parallel because one is negative and one is positive. So let's look at the next one. M equals 2 over 3. M equals 3 over 2. These are not parallel because they are reciprocals. Remember, parallel lines, the slope has to be exactly the same. If one is positive, the other is positive. If one is negative, the other is negative. And then my numbers are exactly the same. 2/3 and 3/2 are reciprocals, so they cannot be parallel lines. Now let's look at the next one. Remember, the only time that I can compare the slopes is if they are in slope-intercept form, y equals mx plus b. And these, I am not in slope-intercept form. So the first thing I've got to do is to change them. So I've got negative 3/5 x plus y minus 1 equals 0. I need to change this to slope-intercept form. So that means I need to solve for y. On the left-hand side, I need to move 3/5 x, so I have to add it. I need to move -1, so I do that by adding. Whatever I do on the left-hand side, I have to do on the right-hand side. So y is equal to 3/5 x plus 1. That's going to be my first one. My second one, 3/5 x minus y minus 3 equals 0. I need to solve for y. That means I need to subtract 3/5 x and add 3. Subtract 3/5 x and add 3. Negative y is equal to negative 3/5 x plus 3. I cannot leave this as a negative y. Y must be positive, so I need to multiply everything by -1. -1 times negative y is a positive y. -1 times negative 3/5 x becomes positive 3/5 x. -1 times positive 3 is -3. So now that I have converted each of these, my slope of my first one equals 3/5. My slope of my second one equals 3/5. So these are parallel because slopes are the same. They have to be the same. Questions about that? One can't be negative, one can't be positive. We can't have reciprocals. They have to be identical. Okay? Now let's look at the next thing. It says write an equation of a line parallel to the line 2x minus y plus 3. 2x minus y plus 3 equals 0. What's the first thing I need to do to be able to identify the slope of this line? I've got to write it in slope-intercept form, y equals mx plus b. That means I've got to solve for y. So over on the left-hand side, I've got 2x with it. I need to move it by subtracting 2x. I have a positive 3, so I must subtract 3. So minus 2x minus 3. So I have negative y is equal to negative 2x minus 3. Again, I've got a negative y. I need to change it to a positive. I do that by multiplying by negative 1. Negative 1 times negative y is a positive y. Negative 1 times a negative 2x becomes positive 2x, and negative 1 times a negative 3 is a positive 3. Okay? So now I have my equation of my line in slope-intercept form. If I need to write the equation of a line that is parallel to that, that means I'm going to have y equals 2x. That's all going to be the same, but whatever I write afterward can be different. I could have minus 3. I could have 2x plus 1. I could have y equals 2x. That would be parallel. I could have y equals 2x minus 2. Notice what's changing is just my y-intercept. My slope will stay the same. So anytime it asks me to write an equation of a line that would be parallel, I would have to keep that beginning slope. I have to keep that first part of my equation the same. So y equals 2x is going to be the same, but I can put any different y-intercept, okay? Because as long as my slope is the same and y-intercepts are different, then they're going to be parallel lines, just like we saw when we graphed both of our lines on our graph, okay? So our next one says identify. So in activities 2, identify whether or not the two lines are parallel. Tell why or why not. This will be our first part of homework. Will be activities 2 on page 82. We'll go ahead and number these 1, 2, 3, 4, 5, 6. And hopefully today, as we work through these, we'll have some time at the end of class to work on your homework and your packet. And then that way you won't have to do all of it outside of class. Let's go ahead and do activities 3 together. The directions say to rewrite each equation in slope-intercept form. So that's the first thing to do. Write an equation of a line parallel to the given line. And then write an equation of a line perpendicular to the line, okay? So first of all, what I want to do is I want to go ahead and where it says parallel, I'm going to put same slope. Where it says perpendicular, I'm going to write negative reciprocal. So that way it reminds me, okay, when I write this equation, what has to be the same and what has to be different. Okay, so in activities 3, I have x plus 4y equals 12. The first thing I've got to do is I've got to write it in slope-intercept form. I'm solving for y. That means I need to move x from the left to the right. So 4y is equal to negative x plus 12. Remember, I'm solving for y, and right now I have 4 and y together. What operation is understood when I have 4 in front of y? What operation is this?
Multiplication.
Multiplication. How do I undo multiplication?
Division.
Perfect. So I'm going to divide by 4, but remember, if I divide my left side by 4, I have to divide every single term on the right side by 4. So those 4's cancel out, and I have y is equal to, remember, my understood number between that negative and x is 1. So I have -1. So I can write that as -1/4, and then I can write my x. -1/4 x plus, now I've got 12 divided by 4. What's 12 divided by 4? 3. So I have y equals mx plus b form. I have my slope-intercept first. Now the second thing says I need to write an equation of a line that is parallel. Remember, if I'm doing parallel, all of this is going to stay exactly the same, only that's going to change. So go ahead and write y equals -1/4 x. And then you can write whatever you want to after that, plus something, minus something, whatever you want it to be. I'll put -2 on mine, but this is what changes, okay? All of this stays the same. Now for number 3. For number 3, I look back at what, oh man, I didn't mean to do that. Make my eraser smaller. Okay, so for number 3, I'm looking at my slope-intercept form. Now remember, for number 3, for perpendicular, this is the symbol for perpendicular, is an upside down T. So my perpendicular slope would equal, my first one is negative, so my next one has to be positive, and then I've got to flip it. So my next slope is just a 4. So now when I write this, it's going to be y is equal to 4x. And then if you just wanted to use your original y-intercept, you could do that. Plus 3. You can, but really you can do whatever y-intercept you want to have. The main thing is that this is the negative reciprocal. Okay, so the first step, slope-intercept form. Second step, we wrote an equation to where my beginning part all stayed the same because my slope had to be the same. Parallel lines, same slope. My third one, my slope had to be the negative reciprocal. So let's look at the next one. We're going to solve for slope-intercept form. So I'm going to subtract 5x from each side. And I have 3y is equal to -5x plus 15. I need to solve for y, so that means I need to divide by 3. But if I divide there by 3, I have to divide each term on the right-hand side by 3. Those 3's cancel, so y is equal to -5/3 times x plus 15 divided by 3 is 5. So there is my slope-intercept form. Chad?
It's break time.
Thank you. Let's go ahead and finish this one up real quick, and then we'll take our break. All right, let's go ahead and write an equation that would be parallel. Parallel means same slope, so I'm going to have y equals -5/3 x, and you pick whatever you want to have after that. It could be plus something or minus something. It does not matter. What does matter is your slope has to stay the same. So I'm just going to go ahead and say -5. And then for the third one, I have to have a perpendicular slope. So perpendicular means that it is a negative reciprocal. My first one is negative, so that means my next one we have to be positive, and then I have to flip it. So I have 3/5 x. And then I can pick whatever else I want. I can keep it +5, I can make it -5, whatever I want my y-intercept to be. All right, we'll come back and we'll do our third one. Go ahead and take your break. righty, let's get ready and come on back. Let me know that you're back by either turning on your screen real quick and then you can turn it back off, or you can unmute and come back, whatever. Just want to make sure everybody's back.
I'm back.
All right. Very good. All righty. So let's go ahead and take a look at this last one. We had in activities 3 on page 82. Activities 3, page 82. The first thing we did was write the equation in slope-intercept form. Then we had to give our equation of a line with a parallel line, and then an equation with a perpendicular. Okay. So let's go ahead and look at activities 3, the last one. All right, step 1 is to write this in slope-intercept form, so we've got to solve for y. So to do that, I've got to move 3x from the left to the right. So I have 4y is equal to negative 3x plus 12. I'm solving only for y, so that means I have to divide my left side by 4, which means I have to divide each term on the right-hand side by 4. These 4's cancel, so I'm left with y is equal to negative 3/4 x, and then I have 12 divided by 4 is 3. So y equals mx plus b form, I have y equals negative 3/4 x plus 3. Okay. The next thing, I have to write an equation that is parallel. Remember, parallel means same slope. So all of this is going to stay exactly the same. Y equals negative 3/4 x. But then I can change whatever comes afterward. I can either put plus something or minus something. So go ahead and pick what you want to put. I'm just going to make mine minus 3. I'm just going to change my sign. This symbol means parallel. Remember, this symbol means perpendicular. And perpendiculars are negative reciprocals. So for number 3, I have to write an equation of a line that has a negative reciprocal. So I'm just going to go back to my original y equals mx plus b, and I'm going to put y is equal to, my first one is negative, so I know my negative reciprocal has to be positive, and then I'm going to flip it. So it would be 4/3x plus 3. Okay? So for parallel slopes, I use the same slope. For perpendicular, negative reciprocals. Okay, any questions about that? All righty. I want you to go ahead and get out a piece of paper. And what I'm going to do is we are going to start some graphing notes. There's a lot of things that we have talked about and a lot of things that we've got to remember in this section. So what we're going to do is we're going to kind of put everything on one piece of paper. That's going to kind of help us to make sense of everything and keep everything straight, because in just a minute we're about to learn a whole another equation. So I want to make sure that we've gotten everything straight before we add something on top of it. Okay? So the first thing we're going to do is let's see. Let's go ahead and the x-axis is horizontal. The y-axis is vertical. Okay, so out to the side if you want to go ahead and draw your x and y axis and label them. Okay. They meet at the origin. And we will also call that 0, 0, the origin. I don't know why I put G-I-O-N, the origin, cancel. O-R-I-G-I-N. Okay. X and Y are called an ordered pair. X tells you where to move on the x-axis. I'm going to put side to side, and y tells you where to move on the y-axis. I'm going to put in parentheses up and down. So we have the ordered pair x, y. X tells you where to move on your x-axis. Y tells you where to move on your y-axis. Okay. Make sure you're writing these down. All righty. So we have x-axis is horizontal, y-axis is vertical. They meet at the origin. Our ordered pair xy tells us where to move along the x-axis and the y-axis when we're graphing an ordered pair. All righty. We have learned that the slope of the line is the rise over run. Slope equals rise over run, which is the same. And this is something that we haven't talked about, but my triangle symbol is also called delta. And in math and science, the delta sign means change. Okay, so change in y and change in x. So that's where we have y minus y, or y2 minus y1 over x2 minus x1. So the change in y values over the change in x values. Okay, so anytime I think of slope, I want to think rise over run. I'm looking at the change in y values over the change in x values. And so the way we write that in an equation is y2 minus y1 over x2 minus x1. That tells us our slope of our line. Horizontal lines have slopes equal to 0. Vertical lines have slopes that are undefined or no slope. I would accept either as an answer on a test, either undefined or no slope for a vertical line. All right, the next one is the y-intercept. And the y-intercept is the point where a line intersects the y-axis. It is expressed as an ordered pair where x is always 0. So I would have 0, y. X is always 0, and that's the y-intercept. If I go too fast, tell me to slow down, okay? The next thing we want to look at is slope intercept form. This is y equals mx plus b, where m equals slope and b tells the value of y in the y-intercept. Slope-intercept form, y equals mx plus b. M equals slope, and b tells the value of y in the y-intercept. The next one we're going to look at is point slope form. And that's where I have y minus y1 equals m times x minus x1, where m equals slope and x1, y1 are from a given point. Okay, so if I have a slope and a given point, I'm using point slope form. And we've practiced previously and today on converting from point slope form to slope intercept. Okay, so I can go from point slope to slope intercept. The reason I would want to do that is because slope intercept tells me where my y-intercept is. I can graph it and then use the slope to identify additional points. All right, the next thing I want to talk about is a horizontal line. And I'm going to put slope equals 0, runs parallel to the x-axis. A horizontal line has a slope of 0. It runs parallel to the x-axis and is written as y equals c. Remember, c was just the constant, so whatever that number is, however, if it's above the x-axis, it's going to be positive, it's below. But the main thing to remember is y equals something is a horizontal line. It is parallel to the x-axis. Therefore, a vertical line, no slope, runs parallel to the y-axis and is written as x equals c. So our main thing here, if I see x equals something, that is my constant distance from the y-axis. And it would be a vertical line. We already talked about the y-intercept is where my line crosses the y-axis, therefore an x-intercept is where the line crosses the x-axis. My purpose in having you write these notes is because it is going to help you with your test, okay? This is all the information that we need to know that will help with our test. All right, now to get to where we were talking earlier, parallel lines have the same slopes. Therefore, they never intersect. Perpendicular lines have slopes that are negative reciprocals. I'm going to put in parentheses example 1/3 and -3/1. Parallel lines, same slopes. Perpendicular lines, negative reciprocals. All right, and now we get to lesson 38, where we are going to be talking about standard form. Standard form. And this is going to be on page 83. We'll go ahead and write a couple of notes about it first, and then we'll work through the book. All right, standard form has certain rules about it. Standard form is written as AX plus BY equals C. Standard form, notice I have a capital A, a capital B, a capital C, X and Y are lowercase. So AX plus BY equals C, where A, B, and C are all integers. Remember integers, positive and negative whole numbers. And A is greater than 0. A, B, and C are all integers, but one thing I have to pay close attention to is A has to be greater than 0. That means A cannot be negative and A cannot be a fraction less than 1. Okay, so those are my rules about standard form. A cannot be negative and it cannot be less than 0. It can't be a fraction or a decimal. It cannot be less than 1. And I'll go ahead and put in here, cannot be a fraction or a decimal, just to be clear. A cannot be negative, and A cannot be a fraction or a decimal less than 1. All right, so now we're going to flip from there. Hang on to those notes because, like I said, this is going to help you as you're prepping for your test. We're getting toward the end of this section on graphing. So basically what I've done is we're going to still continue with the concept of graphing and equations and lines. But this section, we've been dealing with how to use equations to make graphs. The next section is going to be focusing on writing equations, using graphs to write equations. What we've been learning is how I can use an equation to make a graph, and then we're going to flip-flop to do a graph to write an equation, okay? So go ahead in your book, if you're not already open to page 83, go ahead and do that. Page 83 is lesson 38. Me being a weird number person that, like, you know, I'm always looking at numbers and how they relate. And so I'm like, hey, that's pretty nifty there. 83 and 38 go together. All right, so standard form of an algebraic equation is ax plus by equals c, where a, b, and c are integers and a is greater than 0. Because each coefficient is an integer, the standard form has no fractions or decimals, okay? No fractions, no decimals in standard form. The easiest way to graph an equation in standard form is to let x equal 0 and then solve for y, then let y equal 0 and solve for x. Okay, so it says, notice that this method gives us our two intercepts. That gives us our x and y intercepts. X intercept and y intercept. Okay, so if I let x equal 0 and solve for y, that gives me my y-intercept. If I let y equal 0 and solve for x, that gives me my x-intercept. And it says an alternate way to graph an equation in standard form is to rewrite the equation in slope-intercept form and plot the points. Okay, so this is where it says plotting 2 points will give a line. It's a good idea to plot a third point to make sure it lies on the same line, all that good stuff. All right, so this is an example of going from slope-intercept form to standard form. So it says to write the equation y equals 2/3 x minus 5 in standard form. So let's take a look at this. Remember we said that standard form, and actually let's go back to our notes real quick and let's make sure we write this clearly. We had said that a could not be negative and a could not be a fraction or a decimal. We also want to write standard form can only be integers, no fractions or decimals. Okay, no fractions, no decimals in standard form. Standard form can only be integers, no fractions or decimals. So now I'm going to go back to lesson 38. All right, so remember standard form cannot be fractions or decimals. So if I'm converting y equals 2x minus 5 to standard form, my problem right here is this fraction. We have already completed a unit this year about eliminating fractions from an equation. How do I eliminate a fraction in an equation?
Multiply everything by common denominator.
I multiply everything just by the denominator that is there. Yeah. So if I'm trying to get rid of that 3 in the denominator, that means I'm going to have to multiply everything by 3. So 3 times y is 3y. 3 times 2/3 x. Remember, my 3's will cancel, so I'm left with 2x. And then 3 times -5 is -15. So to eliminate the denominator, I multiply each term by that denominator. That gets rid of the fraction. Now I want it to be an ax plus by equals c form. So that means I have to move any numbers from the left to the right and anything with variables x or y from the right to the left. So I need 2x to be on the left-hand side. The only thing I want on the right-hand side is my number, my -15. So now I have -2x plus 3y equals -15. Now, what were my rules about standard form? What were my rules about the letter A? A could not be less than 0. What is the value of letter A right here? AX plus BY equals C. What is the value of A right here? It's -2, right? Is -2 less than 0? Yeah, if it's on the number line, it's less than 0. Remember, A cannot be less than 0. So I need to change this from a -2 to a +2. Remember, if I need to change the sign of a variable or a number, I can multiply everything by -1. So I want to multiply everything here by -1 because I need for A to be positive. So what I'm going to do is -1 times -2x would be +2x. -1 times +3y becomes -3y. -1 times a -15 becomes +15. My rules for standard form tell me that A has to be greater than 0. If it is negative, it is not greater than 0, so I must change the sign. I cannot just change the sign of A. I have to change the signs of A, B, and C. To do that, we did just like we did earlier, and I multiplied everything by -1. So by multiplying -2x plus 3y equals -15 by -1, my signs of everything changes, and I get 2x minus 3y equals 15. Okay. So the first thing we did was to eliminate the fraction. The second thing we did was to put it in ax plus by equals c form that required us to change my -a to a +a. By doing that, I had to change the sign of each term. So let's go ahead and take a look at classwork. It says to write each equation in standard form. Go ahead and above standard form, you can write ax plus by equals c. Ax plus by equals c is standard form. So remember, the first thing I've got to do is eliminate my fraction. To eliminate my fraction, I multiply everything by the number that is in the denominator. 5 is in my denominator, so I'm going to multiply everything by 5. 5 times 3/5 x gives me 3x. 5 times y is 5y. 5 times -1 is -5, and 5 times 0 is 0. Now I want to shift everything to ax plus by equals c. So that means this right here all gets to stay. What needs to move is that -5. The way I move it is to add 5. So I have 3x plus 5y equals 5. Once I've written my equation in standard form, I want to check it and make sure that I've met all my criteria. Is A larger than 3? Yes, A is equal to 3. I'm sorry, I said larger than 3. Is A larger than 0? Yes, A is 3. 3 is larger than 0. I have no fractions. I have no decimals, so I'm good. Okay? Let's look at the next one. I have y equals 3/2 x plus 2. What is my problem here? I have a fraction with a denominator of 2, so that means I need to multiply everything by 2 to get rid of that denominator. 2 times y is 2y. 2 times 3/2 x equals 3x. 2 times 2 is 4. Standard form is ax plus by equals c. I look to see what needs to move from what side to the other. I need to move 3x to the left, so I have to subtract it. So now I have negative 3x plus 2y equals 4. I look to see, has it met my criteria for standard form? Standard form, a must be greater than 0. What is my value of a? It's negative 3. Is negative 3 greater than 0? No. So that means I must multiply everything by negative 1 to change that sign. Negative 1 times negative 3x is positive 3x. Negative 1 times positive 2y is negative 2y. And negative 1 times positive 4 is negative 4. So standard form is 3x minus 2y equals negative 4. All right, so we just looked at how to convert from standard form from slope intercept to standard form. We went from y equals mx plus b to standard form. Now it says to graph the equation 2x minus 3y equals 15. So the first thing I have to do is I need to convert to slope intercept. Convert from ax plus by equals c to y equals mx plus b. Okay, so I've got to go from standard form to slope intercept. Then I identify slope and y-intercept and graph. Okay, so the first thing I have to go from standard form to y equals mx plus b to slope intercept. So 2x minus 3y equals 15. I need to solve for y. Subtract 2x from each side. Negative 3y is equal to negative 2x plus 15. I need y by himself. I've got a negative 3 with it. The opposite of multiplication is division, so divide by negative 3, divide by negative 3, divide by negative 3. Negatives 3's cancel, so y is equal to, now here I've got negative 2x divided by negative 3. I've got a negative divided by a negative, which becomes a positive. So I've got 2/3 x. I'm still going to leave it as a fraction, but because I had a negative divided by a negative, it is now a positive. Now I have positive 15 divided by negative 3. Positive divided by negative is a negative, and 15 divided by 3 is 5. So now we've been able to convert from standard form to slope intercept. So now what is my slope? If I have y equals mx plus b, I can see that M is 2/3, which is the same as -2 over -3. B equals -5. Therefore, my y-intercept is going to be 0, -5. And now I can graph that. Because I know that my y-intercept is 0, -5, I'm going to make my graph. I'm going to go ahead and draw my x-axis kind of far to the top. So I've got enough room to graph that y equals 0, -5. All right, so 0, -5. I start at my origin and I go down 1, 2, 3, 4, 5. There's my y-intercept of 0, -5. I use my slope of 2/3. I can go down to left 3. That would put me off my graph, down to 1, 2, 3. It's going to be about here. Or I can go up to right 3. 1, 2, 1, 2, 3. I've got 3 points. I can connect with arrows. Okay, so I hope you've written all this down so you've got the examples. Change from standard form to slope-intercept if you need to graph. Standard form, solve for y, identify your slope and your y-intercept, and then graph. I tell you what, it's 11:56. I think what I would rather do is stop there. On Monday, we will pick back up with standard form. I'm not going to assign any homework dealing with standard form. Okay, so our only homework from the book right now is going to be page, what is that? Page 82. And it just says, identify whether or not the two lines are parallel and tell why or why not. Okay, so parallel lines have the same slope. So go ahead and over here by parallel, put same slope. Okay. And I tell you what, on this, go ahead and write it in your notebook. Okay, you don't have to do this on separate paper since this is, so we'll just put in book. All right. So in your book, since you have the packet to work on, I don't want you to get confused about pieces of paper and book and stuff like that. Go ahead and do activities 2, page 82 in your textbook. And then you also have your packet to work on. The packet is due in 1 week. Don't put it off till next Wednesday. Start on a little bit of it tonight and tomorrow. Do a little bit Monday, a little bit Tuesday, a little bit Wednesday, okay? If you're having struggles with the packet, be sure to let me know. And we'll, on Monday, we will pick back up with standard form, okay? So my plan is that we will wrap up standard form on Monday. Bring your notes to class on Monday that we just took. Okay, bring those on Monday. So let's take a look at what homework is due on Monday in class. Okay. Let's back it up real quick. So the last time I took up homework, I took up, it was lesson 26 and 30, right? So homework due, I'll write this down real quick and then we'll write it all together. So your homework that will be due on Monday in class on notebook paper, lesson 31, which is page 69, activities 2, right column.
Could you say that again?
Huh?
Could you say that again?
Okay, what I'm going to do is it's page 69, activities 2, right column. And then we have activity or lesson 32. Activities 2, this is on page 71. Activities 2. Lesson 33, page 73. No, it looks like activities 3 will be page 74. Activities 33, page 74, that's activities. Lesson 33, activities 3, page 74, it's those graphs. And then 34, it looks like we did all that in class. 35, we didn't have homework from. 36. Okay. So everything that will be handed in, what I'm going to do is I'm going to write this on your note page. Homework to be handed in on Monday, which is 11, 18, 17, 16. Is that right? 20. Using homework format. Remember, that means lesson notes. Everything's labeled. Everything's written out. It's checked. It's corrected. All that good stuff. Lesson 31, page 69, activities 2, right column. Lesson 32, which is page 71, activities 2. Lesson 33, page 74, which was activities 3, and it's those graphs. Okay. This is all that will be handed in on Monday. In textbook, we said we need to do page 82. Okay, so page 82 in your textbook needs to be completed. That is activities 2. And then graphing packet due Thursday, 11/19. Test sent home 11/19. Okay. So on Monday, I'm looking for 3 lessons of homework to be handed in, lesson 31, 32, 33. All of those have your lesson notes, you're labeled, you've checked it, you've corrected it, you're good to go. You're going to make 100%. I'm looking for hundreds from everybody, okay? I want hundreds on this homework assignment. We will check page 82 in class on Monday. That will be in your textbook. We will check it in class Monday. Your graphing packet is due next Thursday, and your test will come home next Thursday. Okay, everybody clear? All right. I hope everybody has a fantastic weekend. If you have questions, be sure to let me know. I'll be happy to help you. If not, I will see y'all Monday.
Thank you, Miss Jennifer.
Thank you guys. Bye. Hope your power comes
Thank
back
you.
and internet and all that fun stuff.
Miss Jennifer, if I get the packet done before Thursday, could I turn it in?
If you want to turn it in before Thursday, that's fine. You could just bring it to me at the co-op. Okay, it will not be uploaded. You would just hand it in next week. It is totally up to you though.
Okay, because I'm doing really good with it so far, so
Awesome.
I think I can get it finished before
Okay, well, perfect. If you're done with it and you want to turn it in Monday, that's fine. Okay,
Okay, thank you for class.
you're welcome. Thank you. Sorry you had all the trouble with your internet. We'll see you next
Yeah.
week.
We lost power during my first class this morning, so we
Oh,
had to
no.
come here. We had to come to the library to do all my classes.
Yeah, yeah.
So this is my last online class for the day. So
Now, which library are you at?
I'm at the poem library, the new one.
Oh, okay. Okay. So are you, do they have rooms available for you to go into, or are you just at the tables?
Not right now due to COVID, but it's
Yeah.
just like I'm standing at one of the tables right now.
Okay. Well, perfect. Very good. Very good. Well, thank you for going through all that trouble. I know that was a lot. Okay.
Thank
If you have
Miss
questions,
Jennifer. I'll
let me
see you
know.
Monday.
All right. Bye, Mark.
I'll email you.
Okay. Bye-bye.